This video is to function as a review to help you remember and provide some practice on nomenclature. This is not to be watched separately from the notes, but as a supplemental video to help you internalize what the notes that you have taken in chapters 2 and 4. So let's get started. We're going to do molecular compounds first, and we're recalling that molecular compounds are composed of nonmetals only. We use prefixes to indicate the quantity of each element in the molecule. So the example that I have selected here is N2O4. Of course, we'll zoom in a little bit. Of course, this is nitrogen, and this is oxygen. There's 2 nitrogens and 4 oxygens, so we call this dinitrogen tetroxide. You'll follow the same process for the practice questions that are listed right down here. Again, just to refresh your memory, the prefixes indicate a quantity. Right, if we have mono, it means 1, di is 2, tri is 3, tetra is 4, penta is 5, hexa is 6, hepta is 7. You get the idea, right? So, there are some molecular compounds that have widely used names that differ from their systematic naming, right? So, the first one, if you haven't seen this before, you say, oh, that's carbon tetrahydride. No, it is not. It is actually a very, very common gas, methane gas, natural gas, and this is what you use in your Bunsen burners in lab. So, we just always write that CH4 is methane. And that actually functions in basic organic chemistry nomenclature that we will talk about in organic chemistry videos. Or in your organic chemistry class, but not right now. The next one is ethanol. The following NH3, right? Remember, we've actually seen NH3 before if you've done the acids bases video with titrations. This should be in there. If it's not, now you're seeing it, so good for you. NH3 is ammonia, and every good chemistry student knows that ammonia is a weak base. Just saying. This CH2O, so this carbon dihydrogen oxide kind of thing, you don't actually say it like that. This is actually formaldehyde. Formaldehyde. CH2Cl2 is a derivative of methane. It is actually dichloromethane. Or methylene chloride. Whoops. Worse. There we go. And this last one, CHCl3, just for the purpose of knowing the chemical formula for this, this is chloroform. Right, so when you get to organic chemistry and you take what we call NMR spectra, you'll actually use something with the formula CdCl3, and this is deuterium, and this is a 2-neutron hydrogen, so it's heavy chloroform or deuterochloroform. So you use that for NMR solvents. So these practice problems, just go ahead and do those yourself. On to ionic compounds. Remember that we name these differently, right? They have a cation, which is a positively charged ion, and an anion, which is a negatively charged ion. Let's take the classic example of sodium chloride. So this Na right here, this is sodium, which is our cation. This negative part right here is chloride, or chlorine. Chlorine, but I'm going to say chloride as ion. which is our anion, right? Now, some of those anions are polyatomic, right? So for single element anions, those nominal anions, you're just going to chop off the end of the element name, add IDE, and you are A-OK, right? But those anions that are polyatomic, so if we had the nitrate anion with sodium, so polyatomic, if we had NaNO3, right, the Na is the sodium, the NO3 is the nitrate anion, and you just need to know that. Okay, so this is not a always look at your common ion sheet. This is a, hey, you should have this memorized, but when you do a lot of practice, you'll inherently just memorize them along with doing your work. So, last thing with ionics, transition metals, for those you must indicate the charge in the written name after the name of the element in Roman numerals in parentheses, and you'll see that in the practice problems. So we have 3 of these. We're just going to go formula to name. You'll get the hang of this and you'll be able to go name to formula, but there's some practice on these questions in the Chapter 2 notes at the end that get you ready for the Chapter 2 quiz. And you also need to be able to do this on the Chapter 2 quiz. So we're taking a look at it now. So I'm going to go through these a little bit quickly. I'm just going to go through a couple of them. I'll do a few. The rest I'll leave to your care and practice. I'm going to start with this one right here, right? So we remember that this polyatomic anion right here is the bisulfate, and this cation right here is tungsten. So we name this tungsten bisulfate, right? Now, a lot of people would say, oh, I'm done right now, I'm over it, you know, it's tungsten sulfate, it's over, I'm finished, and in reality, you actually skipped a step. So if you take a look at your periodic table or go to ptable.com, you can find tungsten. It's in group 6, it's element number 74, and it's in that transition metal block, right? So since it's in that transition metal block, what we need to do is we need to indicate the charge after the metal, in parentheses, Roman numerals, and that is what we've done here. You can do them as just lines, or you can put the whole top and bottom on there as well. It doesn't really matter. So anyway, so that's one of them. This one above, right here, I'm going to give you the easy one because I want you to do the hard one. So this right here, K is potassium. It looks like I misspelled potassium, so potassium, chloride, so all together, potassium chloride. And I'll do one more, and it's going to be this palladium compound down here. So our cation is this palladium, right? Right, palladium. And palladium is also a transition metal, right? So we're going to determine which oxidation state this is in by taking our phosphate anion. So remember, our PO4 anion is phosphate, right? So each phosphate anion has a 3- charge tacked onto it. 3- charge times 4 is 12- altogether. If we have 3 palladiums and we need to get to 12 plus, right? So we have 3 times palladium equals 12. Divide both sides by 3. Palladium equals a 4 plus palladium, which is totally possible. So we can say the name is palladium 4 phosphate. And that's all you need to do. So 2 of those transition metal examples, 1 of them not transition metal. Go ahead and do the rest of them on your own for extra practice. We're now going to talk about inorganic acid nomenclature. And I put inorganic on there because in organic chemistry, you'll talk about carboxylic acids. That's not for right now. You'll talk about it then. But we're just going to talk about 2 types of acids. So this page, obviously, it's titled binary acids. The next page is oxoacids, or some say oxyacids. They both mean the same thing. No big deal, no sweat, right? So we're gonna go through this pretty quickly because there is detailed acid nomenclature notes already posted. So this is just a review. The inorganic acid nomenclature of binary acids fits like this, right? So you're gonna have hydro-something-ic acid. So hydrochloric acid, hydrobromic acid, hydroiodic acid, hydrosulfuric acid. Okay, stuff like that. So yeah, I mean, that's basically what all of this says, so have fun reading that, but I'm going to skip through that in the interest of keeping this video short. So we'll go some name to formula, we'll do some formula to name, we'll do both. So HCl, as we've said, is hydrochloric acid. HBr, hydro prefix stays, now we just change it to that bromine. Right, chop off the INE, add ic, acid, done. Hydroiodic acid is just HI. Hydrosulfuric acid is H2S. Now, why are there 2 H's? Well, if you look at sulfur, right, when sulfur's an anion, it's 2-. So I need 2 of those hydrogen cations to balance out that 2- charge so we can be neutral. HF is hydrofluoric. I'll write that a little bit clearer for you. Fluoric, fluoric, not floweric. Acid, and the last one, H3P. Remember that phosphorus is in group 15, so if it's an anion, it is 3-. So it is hydrophosphoric acid. You'll actually see that we have a phosphoric acid that has a different formula, so naming these acids correctly is very, very important. So for oxoacids or oxyacids, again, you'll see both names sometimes. Just know that they're acids containing polyatomic anions that contain oxygen, right? So you'll use this following chart, right, based on the name of the polyatomic anion. You can look through this and apply it. I'll reference it when we do a couple practice problems. And we'll actually go through all of these problems together so that you have the answers. And I'll also put, at the end of the video, I'll put a couple seconds of each of the practice problems in that I left blank so you can check your work, but please try and do them yourself so that you can actually get some practice out of this. So some polyatomic anions have 4 different common formulas rather than 2, right? So that nitrate anion, we know we have nitrate and nitrite. NO3 is nitrate, more oxygens. NO2 is nitrite, less oxygens. But some polyatomic anions actually have 4 different common formulas. And the prefix per is placed in front of the name of the anion with the most oxygens. The prefix hypo is placed in front of the name of the ion with the less oxygens, and the middle 2 are named normally with ate and ite, respectively, based on the quantity of oxygens. Again, it follows the same mnemonic as nitrate, so the ate ending goes on the anion with more oxygens, the ite ending goes on the anion with less oxygens. So I'm going to go through this table relatively quickly. Pause the video as you need, slow it down. Watch it a couple times. I just want to keep this video at a manageable length so you're not sitting at your computer forever if you're trying to just watch it through to get a refresher. So we're going to do the anion containing oxygen and bromine. There are 4 common formulas here, so we're going to do this pretty systematically. We go to the middle 2, O2 and O3. Remember that the larger of the middle 2 gets that ATE ending, the smaller of the middle 2 gets the ITE ending, much like nitrate and my nitrite. So this will be bromate and bromite. Remember that with less oxygens, you put hypo in front, so hypo bromite. And this, remember, per goes in front of the one with more oxygens than the ATE anion, so per bromate. The acid of this anion would just be HBRO, HBRO2, HBr, not a beta, BRO3, and HBRO4. Now the names of these acids, remember, so we're naming these not as binary acids, we're naming these as oxoacids. So when we name these, this would be, remember we're using the anion name, using the table up here to help us remember what we're writing down. So you can flip, I'm zooming in here so it's more clear for you to watch on your screen. Right, so that ITE ending, so we would have hypobromous acid. And those are acid and hyperbromous are not one word. Hypobromous acid. Next one would just be without the hypo, so bromous acid. And I'm just writing them diagonal of each other so you can tell that they're different words. You write them on the same line, please. This next one would be bromic acid. And this next one would be per bromic acid. So, this last page talks about base nomenclature, and there's a lot of acid-base practice problems that I will go through. Afterwards, I'll do a couple acid-base practice problems as part of the regular video, then I'll fill the rest in. So I won't talk through them, I'll just fill all the rest of the questions in a different color, so you know which ones to look at to check your work with. So bases are just named as ionic compounds. I guess I definitely should have waited till now to talk about ammonia. Ammonia can be written as NH3 or NH4OH when it's put in water. It's in dynamic equilibrium. With that. So that's kind of how ammonia oscillates back and forth. You don't need to know that for sure right now, but it does follow the mnemonic for a weak base, which you should have talked about and actually gotten that equation, or that specific chemical process in the acids bases video. Anyway, we're just going to go through some practice. Bases are named as ionic compounds: sodium hydroxide, hydroxide anion, sodium cation. Nothing different there. So the first one, this is one you may not have seen before, so I'm going to help you with this one. So NaH, so it's just an ionic compound, it's a base, right? So this is just sodium hydride. I need to write clearly. Right, the next one you can do by yourself. We're going to skip down to H2SO4. So if you've already watched the acids bases video, you'll know that this is sulfuric acid. And I'll have you know that this, right, is sulfuric acid. And if we go back 2 pages, we had a hydrosulfuric acid. So the difference in those two names is very small. So it's important to get them right. And I'll do one more. And we will do sulfurous acid, which is actually just the other anion from right here, right? So this would just be H2SO3. And again, very important to get those names right because it's very easy to confuse them. So I am going to leave you guys to do the rest of the practice problems. I will fill them in and flash each slide on the screen a couple seconds, probably 5 to 10 seconds. Pause it, check your work, and see how you did. Good luck. So if you filled in all the practice problems, just a little note here. If the first element in these molecular compounds only appears once, you can leave off the mono. It gets a little bit redundant to say monophosphorus pentachloride, monoboron tribromide. If you don't put a prefix in front of it, we're going to assume that you mean that there's one of them. Other than that, it's pretty self-explanatory. Here are the ionic compound practice problems. Notice the charges of the transition metals. And here is the acid-base practice problems. If you didn't recognize that this is the oxalate anion, that's what that was. So oxalic acid, hypoiodic acid, hyo. Cool. Yeah, that's pretty much it for you guys. If you have questions, please do not hesitate to contact your professor. If you do not attend my institution, if you do attend my institution, then get in touch with me. If you have questions, talk to your professors, go online, and do practice problems, because there's no better way to get your nomenclature down pat than doing it yourself. So with that, good luck, and we'll see you guys next time.